Again, the other day we did solving quadratics, but today we're going to convert between the different forms. We're going to graph them and also recognize the roots of quadratic functions. Now, like I said before, a lot of this is going to be reviewed from your other classes, okay? So pretty much the first topic is a review of all your functions. Linear functions, regular function notation, quadratics, exponentials, logarithmic, rational, and then your circular functions, which deal with sine, cosine, things of that nature. Okay, so that is what we pretty much is going to take up our very first semester. Okay, reviewing all of your functions. Okay. All right. First thing we'll talk about is the discriminant. And you figure out what the discriminant is. It is that part that's underneath the radical in the quadratic formula, x squared minus 4ac. And that discriminant, that number that you get that's underneath the radical, tells you about the roots of your quadratic equation. Okay, so again, b squared minus 4ac, that is your discriminant. It tells you about the roots of your equation. What's another word for roots? The x-intercepts. Okay, so it basically tells you about your x-intercepts. If b squared minus 4ac, if the discriminant is greater than 0, that means you're going to have two different real roots. Okay, so that means you're going to have two x-intercepts, two real ones. Okay. If it equals 0, that means you're going to have two equal roots, also known as a double root. And then if b squared minus 4ac is less than 0, that means you're going to have no real roots. So if you think about a graph, okay, everybody knows what a quadratic looks like, right? Looks like a what? What's the shape of a quadratic in the graph? Yes, like this or like this, right? It looks like a U. Okay? So if you could imagine two real roots, that means it's crossing the x-axis twice, right? So it looks like this, okay, where you have two real roots right there. Two equal roots, what would that look like? What would that look like? The vertex is on the x-axis, okay, right there. And the no real roots, it doesn't touch the x-axis at all, okay? So it could look like this, or it could look like this, okay? The same thing applies with these other two. They can point down as well, okay? So that's an example of no real roots there. Questions? It's very simple. You want to make sure your quadratic is in standard form, so then that way you can exactly see what is your A, what is your B, and what is your C, okay? So, let's determine the nature of the roots of each equation, okay? The first one is in standard form, yes? Or no? Yes? Okay? So, alright, so what's B? 6. So it's going to be 6 squared minus 4 times A, which is 9, and C, which is 1. Okay, 6 squared is 36. Minus 4 times 9 times 1, which is 36. So 6 minus 36 is 0. Okay? And so then that basically tells you what? For this quadratic, without even having to graph it, you already know there are two equal roots. Two equal real roots. Okay? Which means that if I wanted to, if I could imagine it, that means that it's going to touch the x-axis, the vertex is going to touch the x-axis, just like that. I want you guys to do B, because it's similar to the one that was in your homework. It suggests, okay? Find the discriminant and then determine the nature of the root. So, did I have two different, two equal, or two imaginary? Two different real? Okay, there we go. So, two different real roots. So, hopefully you multiply everything by x. So, you got 3x squared minus 5x equals 4. You subtract it over the 4, right? Cool deal? Yes, make sure it's in standard form. It makes things a lot easier. And so you don't make too many, careless errors. So 5 squared, negative 5 squared, minus 4 times A times C, 25 minus a negative. Alright? And then you get what, 63? 73? Yes, so then you'll have two real roots that are different. Easy enough, right? Okay, so we're comfortable with using discriminant? Yes? Awesome. It's not going to be that easy, okay? Here we go. Find the value or values of k for which the equation will have two different real roots. Okay, I'll give you guys a second to write this down and we'll do it together. So, two different real roots means what? If I have two different real roots, that means what? What is greater than 0? The discriminant, okay? So that means that b squared minus 4ac would have to be greater than 0. Two different. So then we actually pull out, what is b in this problem? Careful, it's actually a negative k. Okay, and even though yes, you're squaring it, it's going to make it positive. Okay, I would hate if this was like just one part in the problem, and then you had to use b again, and you put a positive k instead of a negative k. So just be careful about that. The sign does travel. A is, and c is 3. Has to be greater than 0. So negative k, when you square it, becomes a, and then minus 24. And now we solve this. Now I believe I did this in this class, but I'm not quite sure. When you have a quadratic inequality, okay, you do have to be cautious here. All right? Of course, we're going to add 24 over. Okay? And then we're going to take the square root of 24 to get rid of that the square. Okay? So whenever you take the square root, it's always going to be what? Two answers, plus or minus the square root of 24. Does the square root of 24 break down to what? 2 root 6. Okay? Now if you notice, I have not put the inequality sign back in, okay? Well, it doesn't necessarily flip because we didn't have to divide by negative or anything like that. But when it comes to figuring out which value or values of k will make this have two different real roots, the inequality honestly only tells us if we can include 2 root 6 or if we can't include 2 root 6 in our answer. So, because it was greater than, can we include it in our solutions? Is it going to actually, could 2 root 6 be an answer? No, it can't, because it wasn't equal. The inequality symbol wasn't greater than or equal to the number. Okay? So, to find out which values of k do work, we need to make a number line where we have negative 2 root 6 and positive 2 root 6. Okay? Now, is there another way to do this? Probably, but I feel like this is probably the easiest way to go, in my personal opinion, until you start recognizing the fact. Okay? Pick some test points in each one of these regions. What's a number that's smaller than negative 2 root 6? Let's do one without a root. Think about it. 2 root 6 came from the square root of 24. Negative 5. Let's think about it. Square root of 25 isn't that bigger? So, negative 5. What's the number in between them?
0.
Easiest number, and a number bigger than 2 root 6.
5.
Positive 5. Okay? Trust me, working with whole numbers here is going to be very helpful because you're going to have to test each of these numbers into this part of your process. You have to see which one of these is actually going to give you a number that's greater than 0. Because the ones that do are your values of k that will make this equation have two different real roots. So when I plug in negative 5, what's negative 5 squared? Minus 24, is that bigger than 0? Plug in 0, 0 squared. Minus 24, is that greater than 0? Nope, you get negative 24. And then 5, is it greater than 0 when you plug it in? Yes, it is. So the values of k that are going to make this equation have two different real roots are going to be when k is greater than 2 root 6 and when k is less than negative 2 root 6. Any number that's greater than 2 root 6, any number less than negative 2 root 6. Huh? Nope, literally just like that. Questions?
So the questions on our quiz will be more like that?
Yes, they are going to be IB based. Yes. I might throw in like a, one non-IB question, but that will be most IB related. And your review that I'm giving you guys, okay, I'm giving you a review for your quiz, and I'm also giving you a homework assignment. Now, they're not both due on Monday, but the review is good practice, but the homework assignment that's going to be due on Tuesday has some really good IB worded questions that I think you should definitely try, so you can be ready for your quiz. Yes?
For the number line, would you have picked any negative number and any positive number?
Yes.
So if you would have just said like a larger number on our private side, it would still work?
Yep. Let's think about it. If I chose negative 20, all right, negative 20 squared is 400. 400 minus 24 is still a number greater than 0. So any negative number that's less than negative 2 root 6 is going to work. Same thing up here. If I'm plugging a positive 10, 10 squared is still bigger than 0. So you can't quite say like, well, this is probably the closest number that we could get to 2 root 6, but any bigger number will work.
And they don't have to be the same number as those.
And they don't have to be the same, correct. Other questions? All right, let's move forward and talk about the graphs of quadratic functions, okay? There are 3 forms. Does anybody know the 3 forms of how to write a quadratic? I mean, they're standard, clearly. Vertex and... It's all good, we'll talk about it. Standard form is y equals ax squared plus b equals c equals 0. The graph will cross the y-axis at 0, c. Remember, y-intercepts and x-intercepts are always written as points, okay? So keep that in mind when you're answering those types of questions. So whatever the constant is in standard form, that is your y-intercept. Now the equation of the axis of symmetry is x equals negative b over 2a. Let me stress, it is an equation. So that x equals part is very important to have. Because honestly, in all the quadratic questions I've seen when it asks for the axis of symmetry, it's only worth 1 point. And students never get that point because they forget the x equals. Okay, they have the correct number, but they don't put the x equals, and so they get the problem wrong. Okay, so it's an equation, x equals. Now the axis of symmetry is an imaginary vertical line that goes through the vertex, making the parabola symmetrical. Okay? Can you see it? Can you visualize it? Okay. Something else that you should recognize is that if you can find the axis of symmetry, you've also found the x-coordinate of your vertex. Okay? Let's think about it. It goes straight through your parabola at the vertex, and it goes through the x-axis. You found the x-coordinate. Does anybody know how you can find the y from there? Plug that answer into the original equation. That's how you find the y. Okay? So if you want to see negative b over 2a, to find the y, you evaluate it in the function. That's how you find the vertex. Okay? Vertex form. Should be so familiar. Vertex form is y equals a parentheses x minus h squared plus k, where the vertex of your quadratic is at the point h, k. Okay? The opposite of the inside and then the outside that represents your vertex. A is the same a that would be in your standard form. Okay? So just also keep that in mind. So there we go. This is write the function y equals x squared minus 6x plus 4 in the form of this. This sketches the graph of the function. If you notice, a in your standard form was 1, so that means the a in your vertex form is also going to be 1. But now my question becomes, how do you go from this form, bless you, to vertex form, bless you? You can definitely do the axis symmetry formula, and you can find the x coordinate of the vertex, and you can plug it in to find the y coordinate of the vertex. That's for sure. Definitely. That's one way you can do it. There's another way. involves something that you did when you were solving the quadratic. Completing the square. You also complete the square and also get into vertex form. Either way would get you vertex form. Okay? So, real quick, we're going to do both ways. If I found the axis of symmetry, x equals negative b over 2a. Negative, what's b? Negative 6 all over 2 times a, which is 1. 2 negatives make a positive, so you get 6 over 2, which equals 3. So the x-coordinate of your vertex is 3. To find the y, you can plug it in to your original function. 3 squared is, and then 6 times 3 is, was 9 minus 18 plus 4. So 3 negative 5 is your vertex. Which means that this equation would be y equals x minus 3 or plus 3. And then minus 5. So using the axis of symmetry formula, you can definitely figure out your vertex. Completing the square, you can also figure that out as well. And since we completed the square, when we were solving, remember we had the c on the other side? When you're going from standard form to vertex form by completing the square, you keep everything on the same side, okay? But it still works. It'll be x squared minus 6x plus your number you would get when you take half of b and square it. The only difference from using completing the square when you're solving the equation to when you're trying to get to vertex form is instead of adding it to the c, you are going to subtract it. The reason why is because it's not like it's on the other side of the equal sign. So it's not like you add it to both sides, you're going to have to subtract it from that. Yes, you could very well subtract the c over, do it the normal way, and then bring it back. Still do the same thing. So, complete the square. Take half of b, which is negative 3, and square it. So you're going to add 9, and then you're going to also subtract 9. You're going to factor this first part. What is that? And then what's 4 minus 9? Same thing, right? It works. Okay? It works both ways. It works both ways. Questions? Yes?
Like our quiz, we have to know all these formulas, or
The only formula I believe, someone can kind of back me up on this by looking at the reference booklet, it's easily accessible. I believe you will have the quadratic formula. I know that's in your reference book.
so we can use that on every quiz we take?
Yes. I will provide a clean copy that you don't write on. But this one you can add as many formulas as you want to. However, I think the only other equation that's given to you is the axis of symmetry, and that's it. So everything else, the process will be this way. You'll have to know. I want you guys to do this one on your own. Oh, wait. We didn't. I just caught that. Okay, so we gotta sketch this. So our vertex is going to be at positive 3, negative 5, and when we sketch this graph, now realize sketch and draw are very different. Two very different words. Sketch, they want about an approximation of the graph, okay? Draw, they want very, very specific information, okay? So when you're sketching this quadratic, they definitely want to make sure that the vertex is in the right place. Which direction is this parabola opening? Is it opening up or is it opening down? Sure. And how do you know that? Because the A is positive. They go over that, but hopefully you guys remember that A is greater than 0, it opens up. If A is less than 0, it opens down. Okay, so you're definitely looking for that. And also, do you know your y-intercept? What is it? It's 4. Putting that as well would be a good thing to do. Yes?
I have a question about the upper bounding. Since this is a vertex form, that point is not our like our the height or the low reference, so we know just by that point that we went up.
Not necessarily, because there's nothing outside of the fact that A is 1. That's the only way that you would know that, or it's positive. That's the only way you'll know that it's going to open up or down. So when you sketch it, cross that y-axis at 4, the x-intercepts. If you want to find them out, you can, but honestly, these are the two things that can be drawn the easiest out of it. Now, in the directions, if it says to label or to find the x-intercepts, then you should graph those as well. Next one's on you. All right, how you want to see it? Which way? And square, okay? Square minus 8x plus a number plus 18, and then you have to make sure you subtract that number. So then you would take what? Negative 8 divided by 2 and square it, which is 16. Then you'll factor to get, and then plus 2. So there you go. Yes? Graph it. 4, 2. Which way does it open? What's the y-intercept? Okay.
Somewhere up there.
There we go. Okay? Yes? One more. And we'll do this one together. You gotta be careful if you're gonna do completing the square method with this one because A is not 1. A is what? Okay, so not only is A negative 2, but we also know that when we graph this, it has to open down. Okay, so when you complete the square here, you need to factor out your A, but only from your first 2 terms. Your quadratic term and your linear term. So, you'll factor out the negative 2, leaving you with x squared, careful, plus 6x. Then plus your box. Now you'll still subtract your box on the other side, okay? So if you're going to complete the square this way, you will have to factor out the A from your first 2 terms, not your last one. Yes? Because you're about to see the effects of that negative 2 being out there. Yes? But trust me, I want to constitute for the fact that I took it out. Trust me, no worries. So we go through the same process. We take half of B, which is, and then we square it to get. So 9 will go in the first box, but in the second box, to constitute for the fact that I factored out that negative 2, I'm going to multiply my A and my first box together to get what? It's negative 2 times 9. And that's how you constitute for the fact that I took out that negative 2 from the first 2 terms, and I'm going to take it back into account at the end. Okay?
Sorry to interrupt you, but I think
So, we factor. We have a negative 2 on the outside, and what does the inside factor to be? X plus 3. And the outside would be plus 25. And their standard form is in vertex form. Yes? Yes. Because negative 2 is our A. And we got to keep that. Now, if we did it the other way, Using the standard form and using the axis of symmetry, negative b over 2a. Two negatives make a positive, so we'll have 12 over negative 4, which is a negative 3, which when we would plug into this form, will turn to a positive. And then when we plug negative 3 into our equation to find the x coordinate of the vertex, you get 25. So it still works both ways. Just the one thing you gotta remember when you complete the square is that you gotta multiply the a by the first square to fill in the last square. I would say if A is, me personally, if A is not 1, I would probably default to the axis of symmetry because I tend to forget to multiply that negative 2. It's like I don't catch until after I'm gone through and I'm like, oh wait, I need to go back. So
I changed 27.
there you go. So that's just me personally. So because I know myself and I know where I make my errors. The last form is your Xintercept form. Okay? That's the last of the 3 ways that you can see a quadratic ring. Xintercept form is y equals a parentheses x minus p parentheses x minus q, with x-intercepts at p0 and q0. So p and q represent your x-intercepts. The axis of symmetry is basically the average between your x-intercepts. Because think about it. Quadratic is symmetric. Okay, the axis of symmetry cuts it in half. So if you can figure out the halfway point in between your x coordinates, your x-intercepts, then you know where your x coordinate of your vertex is. Okay? And so we're going to look at an example. And you can go to all between each of the different forms, okay? To get from standard form to X-intercept form, you're just going to have to find the intercepts by doing what? What does this look like to you? Factoring. So you can go from standard form to X-intercept form by factoring. You can go from standard form to vertex form by completing the square. You can go from those other 2 forms back to standard by doing some multiplication. Okay? So you can go between the different forms. Got it? Alright, so let's look at this one. Easy one. It says write the function f of x equals x squared plus 3x minus 10 in the form of x minus p, x minus q. And sketch. Probably won't sketch this one. We'll sketch the next one. Okay? Sketch the next one. So yes, to go from one form to the other, we're going to factor. What 2 numbers? Multiply to give me 5 and negative 2. So it's going to be x plus 5, x minus 2. And there it is, an X-intercept form. Simple factor. Now, more than likely, they will ask a lot of other follow-up questions, such as what's the axis of symmetry? Well, what are my X-intercepts? What are my X-intercepts here? Negative 5, 0, and positive 2, 0. So then that means your axis of symmetry is going to be x equals the sum of those 2 divided by 2. There you go. Okay? So you'll be doing probably multiple other things when you're doing these ones. Okay. What's the y-intercept in this problem? Careful. It is negative 10, but you write your intercepts as a point, so it should be 0, negative 10. Once you guys do this one, you are going to sketch it.